Hello children, how are you all? Hope you are doing well. In today's session, we will learn about subset and superset, power set and universal set, and describing sets as intervals. We will also solve exercise 3 based on these concepts. To understand the various definitions, let us consider few sets. Say x is equal to 1, 3, y is equal to 1, 2, 3, 4, and z is equal to 4, 5, 6. The number of elements in a set is denoted by n of A and is also called the cardinal number or cardinality of the set A. Observe the given sets carefully. Here n of x is equal to 2, n of y is 4 and n of z is 3. Therefore, the set y is the largest set here. Is every element of x also an element of y? Yes, all the elements of x are present in y. So the set X is said to be a subset of Y. So how will you define a subset? A set A is said to be a subset of B if A belongs to A implies that A belongs to B. Symbolically, we write it as this and read it as A is a subset of B or A is contained in B. So in this example, X is a subset of Y. What can you say about the set Z? You may have noticed that 5 and 6 belong to Z but are not present in Y, so Z is not a subset of Y and we write this as this. Note that the subset cannot have more elements than the other set. So clearly Y cannot be a subset of X or Z. Here you may have noticed that Y contains two elements, 2 and 4, which are not present in X. In other words, X is a subset of Y but X is not equal to Y. Such a subset is called a proper subset. A set A is said to be a proper subset of B if A is contained in B and A is not equal to B. The other set B in this case is called a superset of A. A set B is called a superset of set A if A is contained in B and A is not equal to B. In simple language, if B contains at least one element more than A, then it is a superset. Now, can you find some more subsets of Y? It's very easy. You just have to write some elements of Y. So 1, 2, 3, 4 are subsets of Y. Such sets which have only one element are called singleton sets. In addition to these, other subsets are in fact, Y and Phi are also subsets of Y. So every set is a subset of itself and the empty set is also a subset of every set. So now we have found all the subsets of Y. If I make a collection of all these 16 subsets, I will get a set which is called the power set of Y. The collection of all the subsets of a set A is called the power set of A and is denoted by P of A. So P of Y is equal to. Please note that the number of elements in a power set depends on the number of elements in that set. So N of P of A is equal to 2 raised to power m, where m is the number of elements in A. As you can see in the above example also, Ny is equal to 4 and N of P of Y is equal to 2 raised to power 4 equal to 16. I hope all these definitions are clear to you. Next comes the universal set. In a particular situation when we are dealing with various sets, then the base set in that situation which contains the elements of all the other related sets is called the universal set. It is usually denoted by U. Like for the above example, U is equal to 1, 2, 3, 4, 5, 6. Clearly, X is contained in U, Y is contained in U, and Z is also contained in U. Another example of universal set is the set R of real numbers, which can be considered as universal for the situation where we are dealing with standard sets like N, Q, or Q plus, etc. So a universal set may be finite or infinite. In junior classes, you have learned to represent or locate various numbers on the number line. So you are familiar with the fact that even a small part of a number line contains infinitely many points. So let's understand an alternate way of making a set. We can have 4 types of intervals. Suppose I consider the part between -1 and 4. So the first type of interval is -1, 4. It is called an open interval. The common brackets say that the numbers -1 and 4 are not included in this collection. So -1, 4 is a collection of all the numbers lying between -1 and 4. What type of numbers are these? They are real numbers and are infinitely many. So we can say that -1, 4 is a set, and it is clearly a subset of R. The second type is a closed interval and is denoted by this. The only difference between the first and second type of interval is that the second one contains 2 elements more than the first one, that is -1 and 4. We can also have intervals which are closed on one end and open on the other side, like this one. So it has -1 in it but not 4. And similarly, the fourth type of interval is this, which includes 4 but not -1. So are the 4 type of intervals clear to you? So can we say that -1, 4 is a subset of this, which is again a subset of this? Yes. One element is added in every step here. Children, note that you can also write every interval in set builder form. For example, -1, 4 can be written as set of all x such that x belongs to R, -1 less than x less than equal to 4. If I have to write the set of real numbers in interval form, it will be -infinity, infinity. This is the symbol for infinity. Mathematically, infinity is a concept which refers to an endless quantity. It is larger than any number in existence. So infinity is not a real number. On the number line, we have no beginning and no end. So all the real numbers lie between -infinity and infinity. That is why we describe R as -infinity, infinity. Similarly, the positive real numbers can be described by the interval 0, infinity, and the non-negative numbers by the set 0, infinity. We have a term length associated with each interval. It may be any type of interval, whether open or closed. Its length is given by the difference of the 2 endpoints. For example, length of a, b, or for that matter a, b or a, b is given by b minus a. So we have discussed every concept. Now it's time to apply these concepts. If you have correctly understood subset, then you can easily solve question 1 and 2. So go ahead. I will discuss few of them. In question 1, part 4, the first set contains circles with any radius, whereas the second one contains only the circles with radius 1 unit. So clearly the first one is a larger set and subsets cannot be larger than the given set. In 7th part, every even natural number is also an integer, so it is a subset. In question 2, 5th part, the symbol is belongs to. This symbol is used for elements, and the second set does not have any set as element in it, so the statement is false. So be careful while interpreting the various symbols. Now solve question number 3. You have to give reason if you find that the statement is incorrect. First one is incorrect because the elements 3 and 4 do not belong to A. But then why is 2 correct? Confused? Because the set 3, 4 is an element of A, and so the third statement is also correct. Fifth is incorrect as 1 is not a set and the symbol of subset is used here. Apart from these, 8th, 9th and 11th parts are also incorrect. I hope you all know the reasons. Now let's write the subsets of the given sets. First one has only 2 subsets, phi and the set itself. Subsets of A, B are phi, A, B and AB. Remember the formula 2 raised to power m? Always cross-check that you have written the correct number of subsets. In fourth part, phi is the only subset of phi. Now in question 6, you have to convert the set builder form into intervals. Clearly we can write it in interval form only if it is representing some part of the number line. I mean if the numbers are real. So solve them and then cross-check your answers. Now can you convert these sets into set builder form? It was easy, right? In question 8, we have to write the universal set. So just consider any basic set that would include all the members of the given sets. You can also have more than one universal sets. So in both the cases here, it can be the set of all triangles or the set of three-sided plane figures. Which one of the following is a universal set for these given sets? Clearly, it is the third one. Children, with this we come to the end of this video. Hope you enjoyed this session. We will meet again soon with another session on sets. If you have any queries, please leave your question in the comment box. Take care and goodbye.